Alrighty, so yes, yesterday and the previous day we were working on our first form, which was vertex form, the A, H, and K, and going from equation throughout vertex, axis of symmetry, max or min, all the way through graphing. This is our second way of writing a quadratic equation. This is actually the most frequently seen one. So when you're taking SAT, ACT, OST, whatever T it is. Standard form is the most popular used, but all three of them do get used. So standard form is y equals ax squared plus bx plus c. So we still have three values. The only one that is the same is we still have that a value out in front. So just like before, we talked about all three of our forms actually all have a value, and it's always the first number. So that will be consistent through all of your forms. However, standard form has a B and a C. So A, B, C. No H and K this time. So a good way to be able to identify standard form, because remember, I should be able to put a quadratic in front of you, and you should be able to tell me which form it's in. We talk about vertex form, have the parentheses with the exponent of 2. Standard form, it's good to know, do you see any parentheses? None at all. If you see a quadratic with no parentheses, it is standard form. Okay? There are no parentheses. That is a good key indicator that a quadratic is in standard form. There won't be any parentheses at all. None here. Okay, so just like before, the first thing we're going to do is identify our values so that we can use our values to answer all of our questions and get to the same ending, that table in the graph. So let's identify A, B, and C, and what's nice is there's no tricks, nothing has to flip, nothing changes. All you do is look at each value and write them down. So our A value is the first number. So our first number that appears in example 1 is, what's that number out front? -2. No flipping, nothing crazy, it's just -2. Okay, your B value is your next number. It goes right in order, A, B, C. Your B value is the number that is out in front. Don't forget to look at if that number is positive or negative. This has a minus out front, so it is a -4. That is my B. And last but not least, we have our C value, which is always at the end. I think C for caboose, at the end of a train. And that C value is chilling there right at the end attached. So our C value is 6. Now, one thing that you want to notice, when I was writing down my A, B, and C value, did I write an X at all? No. Your A, B, C, and C are values. They're numbers. They shouldn't have variables attached. A lot of times, students like to write down, oh, A is -2x squared, B is -4x. Okay? A, B, and C are just numbers. They're values. Okay, so do not write down any variables with your A, B, and C. Okay, so in standard form, it's a little trickier because sadly, it's not like vertex form or H and K, that's your vertex, yay. Standard form, you can't just look at your three numbers and see the vertex. However, in step number 2, when we find the vertex, we just have a simple little equation we need to use. So this is super important. This right here, this is how we find the first part of our vertex so we can continue the problem. In order to find the x value of the vertex, this only finds the x value, we need to use this little formula, -b over 2a. So negative b value divided by 2 times the a value. So we need to look at our A, B, and C values, put these in so that we can figure out what our vertex is. Okay, so let's plug them in. X equals negative, what was our b value? What was it? Negative 4? So we're plugging in a negative 4, so we have a negative 4. Does that make sense? Our formula already has a negative sign in. When I plug in negative 4, now I have a negative times a negative 4. All over 2 times a. 2 times my a value. Negative 2. So I plugged my b value in up at the top. And I plugged my a value in where that a was on the bottom. Okay? You just imagine the b and a disappear and you replace them with your numbers. Okay? A lot of times we forget this negative 4. Okay? So there's that negative out front. Okay, so now we just need to simplify this and we'll have the first part of our vertex. Okay, so negative 4. What number's out in front but we can't see?
1.
A 1. What is negative 1 times negative 4? Positive 4. On the bottom, we have 2 times negative 2. Negative 4. And then we just need to divide. 4. Does anyone know 4 divided by negative 4? Yep, 4 divided by negative 4. Just to show you, to put in a fraction, you just type it in with division. And then, yep, it is in fact negative 1. This is just your x value. Yeah. Oh, to reset your calculator is second plus 712. Second plus 712. So our vertex is negative 1. Just your x value. We're not done with vertex though, are we? Because to find the vertex, you need to find a point, an x and a y value. We only know the x from our formula. We don't know y yet. Now, back when Kravitz and Baker, we were in school, we would have to take this negative 1, plug it back into our equation, do a bunch of solving to get y. But this morning, we realized there's a way easier way to do it. So you should probably cross this off, where it says plug your x back into the equation, because we're going to be able to skip this. We're going to be able to skip this. And instead, we're going to look at the table in our calculator to help us find this vertex. Okay, so we're going to unsheath our calculator. If you would like to reset it, remember it's second plus 712. Please. There we go.
What does that reset?
It just clears the graph off. Sometimes kids have scrolled through their table and it's at negative 200. Just gets it back to normal. Click on your y equals, because we need to plug this into our graph. Okay, so ax squared plus bx plus c. Let's type in example 1. Negative 2x squared. Negative 2x squared. Minus 4x. Plus 6. Couple things to notice. 1, whenever there's a minus or a negative at the beginning of the equation, your calculator, it gets very angry if you put minus. So make sure you're using a negative for the a value. The rest, that 4, that would be a minus. If you ever get an error when you try to graph it or go to the table, you probably flip-flopped your minuses and negatives. Okay? So we have it in. We need to go to our table. Second graph. Here's our table. Now we know the x value of the vertex is at negative 1. Okay, so if we go find -1 in our calculator, which it's right here, there's -1, what y value goes with it? 8. See, the alternative would have been to take -1, plug it in for both x's, simplify the whole thing, which probably involves some order of operations or being able to plug it into the calculator. And we got to skip all that because we knew how to use our table. Okay, so you can leave the table up because you know we're going to be using that in a second. We're going to continue on down to step number 3, which is our axis of symmetry. This follows the same exact pattern as before. The axis of symmetry, the line that cuts a quadratic perfectly in half, always starts with x equals because it's a line. And it's going to go through the vertex. Does it go through the vertex at -1 or 8? Do you remember? Which number will it go through? The -1. Because -1 is the x value, which is why we write x equals -1. Okay? Yeah.
Are we just doing the examples and having them do this as a class, or is this a homework?
Either one. Step number 4, we need to determine if it's a max or min. Exactly the same as vertex form. This is actually the same for all 3 forms. Determining max or min, you look at your a value and decide. In this case, what was our a value? Positive or negative? A value? Our a value is negative, it's -2. And so that means it's going to be a maximum, correct? Remember, the little trick is, a value is negative. When it's a negative day, you're frowning, and frowny faces have a maximum. What's up?
He had you for first period.
Oh, what's up? Take a seat. Rabbits will hook you up in a second.
Oh no, he's not done yet.
Oh, you're still a
I'm
steward.
gonna drop him off.
Okay, cool. So this is a maximum. Good on steps 1, 2, 3, 4 so far? Good? Really, the only difference has been the vertex, hasn't it? The rest has been pretty similar. Okay? Same thing. We're going to do our table and our graph, and we will be done with this problem. So we need to make sure we put our vertex, which was -1, 8, right in the middle of our graph. -1, 8, right in the middle of our graph. Okay, and because we have already put in our equation and gotten to our table to find the vertex, our table is already up and ready to go. So if you didn't have your table up, remember you put y equals, plug in your graph, second graph to get to your table. Here's our vertex, -1, 8. We're going to copy down the 2 points above it and the 2 points below it. But remember, if there ever was gross nasty decimals, you can always go and pick the nice whole numbers. So above it, we have -2, 6. And then -3, 0. Below it, we have 0, 6. And we have 1, 0. And there's our table for our standard form. All that's left is to graph it. I like to start with my vertex, -1, up 8. And then I either go up or down. I'm going to go up, -2, 6, so over 2, up 6. And then -3, 0, over 3, 0. Remember, quadratics are symmetrical, so when we start doing our other 2 points, you should see things being the same on the left and right side of the vertex. 0, 6, 0, up 6. Those match up, symmetrical. and we have 1, 0. Those match up. Those are symmetrical. So that looks like our points are good. Last but not least, we connect our dots, and we will have our full quadratic. We draw that dotted line down through the vertex. That is that axis of symmetry that goes through -1, just like we thought. And that is how we do one that is in standard form.